Welcome to The Explainer. Today, we're digging into how one single microscopic typo in a virus's genetic code can be the difference between feeling a little under the weather and a really serious illness. It's a huge question, right? Why can one person brush off a virus while it sends another person to the hospital? To get to the bottom of this, we're going to follow the clues from a fascinating piece of research that plays out just like a detective story. So, our investigation starts with a very common virus and a riddle that scientists just couldn't quite figure out. Something wasn't adding up, and it kicked off a whole investigation. Now, meet the main character in our mystery, coxsackievirus B2, or CVB2 for short. It's an RNA virus, which means it's, kind of famous for being a bit of a sloppy copier. When it reproduces, it makes mistakes. Mutations. Think of it like a typist who's really fast but doesn't bother with proofreading. And that sloppiness leads us right to the heart of the riddle. Usually, CVB2 infections are pretty mild, but every now and then they turn nasty. The big question for researchers was, how? How could one tiny genetic typo in the virus, when it meets the right person, or in this case the right host, completely flip the script from a mild cold to a severe disease? All right, so to crack this case, our scientific detectives needed to line up the suspects. Just like in any good mystery, you've got to figure out who the potential culprits are, and they basically fell into two main camps. So, was the problem with the attacker or the victim's defense system? On one hand, you've got the virus itself, with all its different mutations. Maybe one of these mutated versions was the real troublemaker. On the other hand, you've got the host's own body. Maybe the issue wasn't the virus at all, but a specific weak spot in the host's genetic armor. So let's meet our victims, or rather, our test subjects. First, we have the AJ mice. They're known to be extra sensitive to these kinds of viruses. Think of their immune system as having a known security flaw. Then you've got the CD1 mice. These guys are much tougher, way more robust. Their security system is top-notch. And here's the viral lineup. You've got the original virus, the one they started with. Then you have a few other mutants with different typos. But the one you really want to keep your eye on is that last one, the VP1Q164K mutant. It has just one single, tiny change in its code. This is our prime suspect. Okay, so we've got our hosts and we've got our viral suspects all lined up. Now it's time to see what happens when they meet. The researchers designed an experiment to track these culprits in action. Here's how they did it. They infected both types of mice, the sensitive ones and the tough ones, with each of the different viruses. Then they just watched. They meticulously tracked everything for 55 days, checking in at key moments to see what was happening in the short term and if there were any effects that lingered long term. And it didn't take long for the evidence to start pouring in. The trail led them to a very specific place. While the hearts of the mice were mostly fine, their pancreas told a totally different story. It became the primary crime scene. Now get this. Look at the data for the vulnerable AJ mice. See that row for our prime suspect, the Q164K mutant? By day 5, it had already caused significant damage, a 2+. But here's the kicker. At day 55, that damage was still there. Meanwhile, the damage from the other viruses, it pretty much vanished. That's a huge clue. But what about the tough CD1 mice? Well, this is where it gets really clear. In those mice, there was basically no damage to the pancreas at all. Their tougher immune systems handled every single version of the virus, even our prime suspect, without breaking a sweat. This shows just how critical the host genetics are. So here it is, the smoking gun. It wasn't just the virus, and it wasn't just the host's vulnerability. It was the specific, unlucky combination of the two. The vulnerable A/J mice, plus that one specific viral mutant, created the absolute perfect storm for a severe, long-lasting disease. And with that, the mystery was solved. The evidence was overwhelming, and the researchers could finally point their finger directly at the culprit behind this whole mess. As the scientists themselves put it, that single altered amino acid basically acted as a virulence factor. In plain English, that one tiny typo was the secret weapon that made the virus so much more dangerous, but only in the right host. So what exactly is a virulence factor? Well, you can think of it as any tool or trait that makes a germ better at its job of making you sick. It could be a toxin or a slippery coating that helps it hide from your immune system. In this case, it was a change that made it a master at breaking and entering.
So here's the play-by-play of the attack. That one little genetic typo changed the shape of a protein on the virus's surface called VP1. This protein is like the virus's key for getting into cells. The mutation basically reshaped that key, and it just so happened to become a perfect fit for the locks on the pancreas cells of the AJ mice, letting it waltz right in and wreak havoc.
And if you need any more proof, check this out. The researchers could still find traces of that mutant virus's RNA in the pancreas of the AJ mice a full 55 days after they were infected. This thing didn't just hit harder. It stuck around. It refused to leave. Okay, so this is all super interesting for mice, but let's talk about the big picture. Why does solving this little mystery matter for us? How does this connect to human health? Because what we're seeing in this lab is a perfect miniature version of the invisible arms race that's happening inside our own bodies all the time. Viruses are constantly changing, trying to find new ways in, and our immune systems are constantly adapting to keep them out. This experiment just gives us a crystal clear snapshot of that battle. So when you boil it all down, what's the big takeaway? First, your own personal genetic makeup is a massive factor in how sick you get. But at the same time, viruses aren't static. A single random typo can turn a harmless bug into a real threat. Understanding this complicated dance between our bodies and their viruses is absolutely key to figuring out why some people get sicker than others. And that leaves us with a final, pretty sobering thought. This experiment showed us how one tiny change made a common virus a serious problem for a vulnerable group. It really makes you wonder, doesn't it? What other viruses are out there, quietly circulating, that are just one single typo away from becoming the next big threat?